You hear me?
Yeah, I can hear you.
Okay, good.
Can they see the Elmo?
Can you see the Elmo?
Yeah.
Okay, you're good then.
All right.
Okay.
Okay, let me get my work camera going here. How's everything going? Is everything fine with you guys? Can you hear me good?
I'm mostly home alone a lot.
Excuse me?
I'm mostly home alone a lot,
Oh, okay.
but yeah, I'm doing good. How about you?
If I can turn up my volume a little bit more. Um, I'm not trying. All right. I'm going to start with week 2. All right.
Okay.
Which is, this shouldn't be quite as difficult. There are some parts that's a little hard. We start with 3.1. This is not working too good today. It's freezing up. Okay, here's 3.1. All right, let me try with this one. And basically the rule for this is that if you want to take the derivative, say y equals e to the x, then the derivative of that, dy over dx, is e to the x. Well, that's pretty simple. But the problem is, if this isn't just an x, what if this was like x squared or something? So if it's e to something else, we'll just call it u. It could be x squared, it could be x plus 2, it could be a whole bunch of things. Then the derivative is e to the u, and then we have to use chain rule. Which is, come on, is the derivative. Why is this? Try it this way. This is, I think we need a new pen is what we need. Hello. What? Let me. Du over dx. There we go. Okay, good. So we have to use the chain rule. So let me give you an example. It's very similar to the first one you have. Okay. So you have something like y equals e to the 2x. We're do y equals e to the 3x. Okay, very similar to what you have. So y prime, are you with me? Everybody good?
Yeah, we're good.
You have the worksheet? Okay, if not, just write this down. So this would be e to the 3x, and then we are going to take the derivative of 3x, which is what? 3? So the final answer would be y equals 3 e to the 3x. And that would be our solution. So if this was 2x, you could kind of figure this would be a 2, kind of figure out what it's going to be. Okay, let's try. Good. If you have a question, make sure you ask, and then let me get some regular line paper here. It'll be a little bit easier. Okay, so let's try one that looks terrible. Let's actually do problem number 5. Okay, so we've got 2e to the square root of x. So what I'm going to do is I'm going to change this problem a little bit before I get started. This will be y equals. And this will be 2e to the x to the 1/2 power. Write it in that form. Okay, so the first derivative is going to be, when you have a constant in front of this e thing, anytime you have a constant, that constant, that 2 is going to stay. Okay, we're not going to do anything that's a constant. It's not like +2, then it would be 0. This is 2 times that. So we can just kind of move that 2 over. Now, e to the x to 1/2, we just keep it. And now we have to take the derivative of this x to the 1/2. We got to take the derivative of that part. So x to the 1/2 would be 1/2 x 1/2 minus 1, which would be a negative 1/2. So that's what the derivative of this is. We can write it as y prime or dy over dx, or, might want to get used to using that notation. So we can see that this 2 and this 2 on the bottom can cancel out because this is just a times problem. And let's see, we got, maybe we just write this now as y prime is equal to e to the square root of x, going back to that, over x to the negative 1/2. We can bring that back down, and that would be over the square root of x. Like that. So the answer is quite different from the original problem. Does that make sense? So we have to do, unfortunately, chain rule on this portion of the problem right there. And all these are going to be like that when we get into the other formulas. Okay. Well, let's try one like number 6. Are you good with this one? Erase it. Okay. Number 6. If you have comments, you can go ahead and. Okay. So let's do this actual problem. This one looks like a pretty easy problem. Actually, it's a ABBA. A b prime plus b a prime. And let's just write it right here, and then we can kind of see it. So this is a and this is b. So it's a times the derivative of b. Well, that's easy. That's still e to the x. Plus b, well, that's still e to the x. Times the derivative of a, which is 1. So basically your answer is x e to the x plus e to the x. Or we could factor out, if you want to factor out, it looks a little bit, maybe like you'd want to factor it. X taking out e to the x, that would be x plus 1. So actually either answer is okay, it just depends. Like if it was multiple choice, they might give this choice instead of this one. They're both good answers. So it's a b prime plus b a prime. This is a 1. And then we just, that's basically it. Just combining the like terms. You can write, really don't want to write the 1. Anna, are you there? I don't
Do
see,
what?
I don't see your pictures. I just see your.
Yeah, I have my video off. Do you want me to turn it on?
No, that's okay.
Okay. Yeah, I'm here. I'm watching.
But if you have a question or anything, any of you guys, feel free to ask.
Okay, sounds good. Thank you.
Okay, you good on this one?
Yes.
All right, let's move on. Now, looking at problem number 7, this is one that's kind of tricky. I'm just going to do some on this, and then I'm going to let you try some. So this is probably the last one I'm going to try on this. Okay, now this problem looks sort of like an ABBA also. This could be A and this could be B. You could bring this up to the top and say this is x to the -1 times e to the x. But if you do it that way, it's actually kind of difficult to do because you're working with these negative exponents and everything. So if you rewrite the problem this way, like multiply these together, you're going to find it's much easier to do a BABS. This would be A and this would be B, and we're going to do a BABS. B, A prime minus A, B prime over B squared. And it's a little bit easier to handle the problem that way. I tried it both ways, and this is so much faster. Okay, so it's B times the derivative of A. So the derivative of A is still going to be e to the x. The pen is, it takes a special pen, and it's not working today very well. I'm going to ask if we can get another pen. There we go. Okay, it's B times the derivative of A minus A, which is e to the x, times the derivative of B, which is 1, over B squared, and B squared would be x squared. So you can see pretty easy. I guess that's basically all you can do. If you want to, like that last one, you want to take out an e to the x. This is x minus 1 over x squared. So you can do it basically in one step. If you do it by ABBA, I'm going to tell you it takes about 6 steps. Much more difficult. But it looks like an ABBA problem. So that's why sometimes you have to be kind of creative on these. Most of the time you want to use ABBA, but this particular problem, much easier to use BABS. This was problem number 7. All right, so that's pretty much it. If you take a look at problem number 8, you got to do an ABBA minus an ABBA. When you do the ABBA on the first group, when you go to do it on the second group, you have to put it in the parentheses because it's minus the whole thing. So you want to put a parentheses on that second x e to the x. It's not too hard of a problem. It's just, making sure. So the key is if it's e to the something up here, say x plus 2, then it's going to be e to the x plus 2 times the derivative of x plus 2, which is 1. So you're going to have to take the derivative of that. If this was, say, let's make it a little bit harder, x squared plus 2, then it would be 2x. Now, the order you write them in doesn't really matter. Usually you put the x term and then the e to the x squared plus 2, but order is, some people might just leave it this way. This looks a little bit nicer if they're all kind of pushed together. All right, let's look at 3.1. Excuse me. Now on this one, these two worksheets we use each of the X a lot, and we're going to be using ln X quite a bit. So these we use. The third worksheet that you're going to get is kind of special cases that we don't use that often, but these two we do use. So the derivative of ln X is 1 over X. And that's just something you're going to be using it quite a bit, so you want to kind of memorize this one. The derivative of ln X is 1 over X. If you have the derivative of ln and maybe it's at x squared plus 2 or something like that, it's a more complicated thing, then it's going to be, the derivative is going to be 1 over u times the chain rule, the derivative of u with respect to x. So it's going to be chain rule here. And that's how they're showing the chain rule. So it's kind of like e to the x, except that e to the x is e to the x. ln x is 1 over x. So it's just a special case. These are probably a little bit easier than the last problems you did, for sure. All right, so let's start out with one. Let's say we have y equals, I'm just going to make up a problem just to show you, x squared plus 3. So a little bit more complicated than just x. So y prime is 1 over x squared plus 3, just the way it's written, times the derivative of this, which would be 2x. So that becomes 2x over x squared plus 3, like that. So we got that crazy chain. Of course, the derivative of 3 is 0, so we don't have to worry about that. So let's try some on this worksheet. I'm going to clear this off. I'm just going to write down the rule, maybe. Okay. So is there one you want to see especially? I know number 6 is going to be really hard. Looks really hard. It might not be that hard. Oh, let's start out with number 3. That one looks, oh, okay, well, let's start out with number 1. Okay, maybe you're saying, well, what do I do with this? Okay, let's start out with the very first one. I just read it as y prime. The 5 is just going to, just like 5e to the x, you're going to keep the 5 ln x, you're going to keep it. This is times, and this is just an x, so we don't have to worry about it, 1 over x. So the answer is just 5 over x. Just that simple. So they don't have to be super, super hard, you know. Let's look at number 2 here. It's kind of interesting. Y equals ln 5x. You don't want to put an equal sign there. You just want to go, you want to show that you're taking the derivative. So this is going to be 1 over 5x times the derivative of 5x, which is 5. So we have to go back in and do the parentheses, see? And so that comes out to be just simply 1 over x. Pretty cool, huh? So these two 5s I obviously cancel out. If you did ln 3x, you find out it comes out 1 over x also. All right, so let's try number 3. Over x squared. Come on. I'm going to put the equal there. Okay, so this looks like a Babs, huh? Remember, Babs has a minus. So this is A, and this is B. So B times the derivative of A, which is 1 over x, minus A, which is still ln x, we're not going to change it, times the derivative of B, which is 2x. And then all that is going to be over, I'm just going to make a little notation, x to the 4th. So this is going to become, you can see these are going to cancel. Y prime is x minus 2x ln x, rather than kind of rearranging it, over x to the 4th. And we can factor out an x. 1 minus 2 ln x over x to the 4th. And we can see we can kind of reduce that down. So that becomes 1 minus 2 ln x. You can keep it in the parentheses or not. It's just the whole thing's over x to the 3rd. Did I go too fast? So B times the derivative of A minus A times the derivative of B. Move the 2x in front. Pause my thing. Move this over here. Let's see if I change grips here. Tried writing up higher. Maybe that would work. Okay. And then I factored out the x and reduced it. So again, this is just the algebra part here. I mean, the calculus part here, and then this is the algebra stuff. All right, which one would you like to see? You tell me. Anybody see anything special? Well, I'm going to show you one. I'm going to do a variation on number 6 because I want to save some of the fun for you. But we'll try this one. This thing is terrible today. Sometimes it's good and sometimes it's bad. I'm going to I can write with this one, but it's a little bit difficult to write with this. It's really hard to write with this.
Mr. Mitchell, what number are you doing?
I'm going to do, I'm sorry, number 6. That one
Okay.
looks really hard. trying to get this pen to work. Maybe it needs new batteries or something. I've got it taped together and everything else, but I'll talk to the tech guy as soon as I get done. This is number 6. It's ln 3x. I'll go ahead and work the actual problem. Okay, this one is kind of a, okay, so we want, think of this as if this was just ln x, it would be 1 over x. So this would be ln, it would be 1 over whatever's in the parentheses. See, if this was in the parentheses, that would be 1 over x. So this would be 1 over x. But this would be 1 over, instead of x, it's 1 over ln 3x. So it's that. Then I've got to do the chain rule. So I've got to take the chain rule of ln 3x. Well, ln 3x would be 1 over 3x. See, I took the derivative of this part, ln parentheses. Now I'm taking the derivative of what's in the parentheses, 1 over 3x, and then I've got to take the derivative of the 3x, which is 3. So it's kind of a sneaky little problem. It's 1 over the parentheses, the derivative of the parentheses, ln 3x, times the derivative of what's inside this, plus the derivative of just the 3x. So the final answer would be 3, well, not the final answer, it would be 3 over 3x ln x, ln 3x, 3 over 3x ln 3x, and then of course these 3's on the outside are going to cancel. So now I have 1 over x ln 3x. So that's a kind of a, you really have to kind of think on this problem. So it's 1 over the derivative of the parentheses times the derivative of the parentheses times the derivative of the 3x. What a mess, huh? But anyhow, that's the final answer to that one. So that one is a genuine, hard, terrible, I hate it type problem. All right, let's do one more here. Let's try number 8. And these should always be written y equals. Okay. So again, we see we've got something times something. So this looks like an ABBA. AB. AB prime plus B, A prime. So A, nothing changes there, times the derivative of ln x, which is 1 over x, plus B, B doesn't change, so that's ln x, times the derivative of e to the 2x. Well, that'll be 1 over, e to the 2x, times, chain rule, the derivative of 2x, which is 2. Let's put a little times signs there. So that's the tricky part. each of the 2x is each of the 2x, but because this is not just an x, it's a 2x, we got to take the derivative of 2x. So now we can do several things to it. They both have each of the 2x, you notice. And that's kind of common to both of these. So we could factor that out. And that would leave us with 1 over x plus, and the 2 is still here, so it's right 2 ln x. Like that. And I think that would be the final answer to this thing. That's all I would do to it. So I'm going to leave you here, let you try some of these on your own. You get the general idea. I did some of the harder ones. Number 7 is kind of tough. 7 is probably the hardest one. And then if you have some questions, we can answer them tomorrow. You know, especially right, number 7 is going to be a rough one. 7 and 10 are a little bit hard. The other ones won't be too bad. But I know when you get to especially number 7, it's a little bit hard. It takes quite a few steps to do it. It takes about 5 steps or so to do that particular problem. Make sure you watch how the parentheses are on that one. There's quite a bit of chain rule on that. So I'll leave you here to work on these. And then tomorrow we'll pick up 3.5. 3.5 has some unusual derivatives that we don't really, we use them occasionally. We don't use them that often. So they do, but they do come up once in a while. And they're the kind you don't remember. E to the x is easy to remember. And ln x isn't bad to remember, you know, 1 over x. The other ones are a little bit harder to remember. So that's all we're going to do. Do you have any questions? I'm going to sign you off then. Okay.
Alrighty, thank you.
Thank you,
All
Mr.
right,
Mitchell.
and we'll see you again the same. All righty.
Bye.
Bye. I'm trying to get out more. Excuse me. I'm going to start coughing here.
Thank you.
Excuse me. I gotta get out of here.